Okay, today the second topic is the state variable models. First of all, let's write a system like to what we have the K and C, M, C, K, F, T, X, T. Okay? In the transfer function, just help me, Ozan, how we can write the transfer function of these terms? Yes, but in the S square times M, S times C plus K, right? This is equals to this one, because M is the second derivative, C first derivative, and K is equals to what? To this one. And so we can easily write the transfer function of these terms just like this one. Fs is equals to what? The 1 divided by ms square plus cs plus k. Okay? This is simple. And so we can obtain to the what? For a given force value, we can estimate or find to what? The position value. Right? How we can obtain the velocity value? Sarah. Yes, by integrating, or how we can reorganize this equation in order to obtain the velocity value. The velocity is the what? First derivative of the x. Huh? If we multiply this transfer function with the what? S. And so this is equals to what? The Vs. Right? Because it is the derivative. Right? See? We can obtain this thing. But we need to build to what? The two transfer function at least in here. Right? Because the transfer function is unique. In order to obtain the Vs, just see, we can write it just like this one. The Vs Fs is equals to what? The S divided by ms square plus cs plus k. Okay? And so we need to build two transfer functions to obtain the what? The Vs velocity or the position. So this is called to the what? The single input and single output system, because we have the F and the output is the 1 xs or Vs. Then we can write that if we add another controller, for example for velocity value, and so we need to add another transfer function in here. Otherwise, we cannot control this because we don't have the transfer function of the velocity form. At least we need to build two transfer functions to reach the what? The position value and the velocity value in here. This is the first case. This is the SISO. SISO system. Okay? In the second place, we need to talk about the what? This is the linear system, which means that we can apply to what? The transfer function. If we have the nonlinear system, we cannot apply the S domain. Sarah. Why? Why? Why we can't apply the S domain into the what? Into the nonlinear system? Because Yes. Zülküf? In the nonlinear system, we cannot transform anything by using the S domain, or the Laplace transformation is current is only in the what? The linear one. Okay? We cannot handle the nonlinear system. Nonlinear system. Okay? And thirdly, we cannot describe the higher order system in here. Or multiple state. What is the meaning of the higher order system? For example, if you have any information x dot 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 dot, this is the fourth order, right? And so if we have the four dot, and so we need to write four different transfer function in here for each state, right? X dot, x dot dot, x dot dot dot, right? And so at least we need to build the four different transfer function in here. Or maybe our system possess the multiple state. For example, x dot, or theta dot. For example, if you have the pendulum chart model in your system, we have the directional or the horizontal movement, which is designed in what? Translational motion. Or we can have the rotational motion, right? For example, if you have a car, and so you have the what? The rotational motion at the tire. And also the car is going with the what? With the x, translational motion. See? And so if we have the fourth state in here, and so we have, Ozan, how many transfer function? 4. Right? So we can conclude that if this is the case, we cannot use every state in transfer function because we have single input and single output system in the transfer function. Okay? We cannot do that. Do you understand what is the problem in here? We have 4 problematic solutions for this case. If we have only transfer function in the system, we cannot model the nonlinear one. We cannot define the multiple state. We cannot define the higher order system, right? Or we cannot define the distinct or the separate controller on the one transfer function. These are problems. And so how we can solve this problem, Sarah? Huh? Maybe, but this is called, we should write everything based on what the states or state variable. For example, if we have, or let's return into MCK system, okay? Mx dot dot plus Cx dot plus Kx is equals to what? The Ft, right? And so in order to reach the states in Turkish durum or signal or physical signals in here, we can utilize the what? The 2 signals, x and x dot, position and the velocity value, right, Sarah? Okay. But in order to do that, just remember the xs fs should be written and sxs fs should be written in here. How we can combine these 2 transfer functions in the time domain? Because we cannot use the transfer function or the frequency domain in here, right? So first of all, we have the higher derivative values in here, just like this one. The x dot dot is equals to what? Minus k divided by m x minus c divided by m x dot plus f divided by m. Our equation of motion turns into this one. This is just simply the reorganization of these terms, right? Okay, so in order to solve this problem, we need to define everything in the first order system, because we have the first order system, and so we have only one state. If we have second order system in here, and so we have the two state, x and x dot, right? If we have the first order system, we contains only the one state. Okay, so let's define the dummy variable. What is dummy? Sarah? Yes, fake, arbitrary, or the random variable with the specific symbol. Dummy ne demek arkadaşlar? Dummy rastgele, aslında sahte bir değişken tanımlıyoruz burada. So z1 is equals to the x. In order to create to another state, z2 can be assigned with the x dot. We can assign it. And so if we take the derivative of this term, z1 dot is equals to the what? Yes, z2. See, this state is to what? Is in the form of the first order system. Okay, and z2 dot is equals to the what? Yes, or x dot dot. And so x dot dot is given in here, right? Okay, and so how we can write this value? First of all, the x is equals to the what? z1 times minus k divided by m plus x dot z2 times minus c divided by m plus f divided by m, right? This is the R form. And so how we can generalize this equation in the first order form? See, we have the dummy variable z in here, and so these two terms is the first order, Sarah, right? And so z is equals to the what? Dot equals to, this is the 2 times 1 vector in here, right? And also we have at the right hand side to what? To z, right? And so z, we need to define the new matrix in here, just like this one, A. Z dot is equals to what? A times Z. Plus, we have also a force value or the input value in here, right? And so, this is assigned with what? The U. The general name for this F, U. This could be to what? The voltage value or the another value, or in this case force value or the torque value, right? It's the general symbol for that, for the input signals. And so we multiply with the B, okay? And so what is the dimension of these terms? We need to write this. What is the dimension of the Z in here? Yeah, 2 times 1, or we can assert that the n is the what? The state number in here. How many states are given in here? 2, okay? N times n times, huh? No, 1. Please be loud. Okay, so I cannot hear you. Sarah. Heh. I can't hear you. Please be lovely. Speak. This is equals to what? To z. And z is to what? z1 and z2. Okay? This is always equals to this one. And so, what is the dimension of the a in here? Or the z dot? What is the dimension of the z dot? Ozan. No. N is equals to the 2. And so in the general form, we have no. Yes. N times 1. Because the z dot is equals to what? Is the simple derivative operator in here. Just like this one. This is so simple. This could be, or this always must be equals to what? N times 1. N is the number of the state. Okay? And so, what is the dimension of the A? Or? Huh? What is the dimension of the A? Huh? Allah, tövbe estağfurullah. We have n times 1. And we have question mark and n times 1. 1 times n. If we multiply the 1 times n times 1, what is the output matrix? Huh? Oh be. N times n. See? N times n multiply n times 1, and these two terms removes each other. First and the last one is passed in here. Just like this one, right? In the matrix theory. Sarah, you get it? Okay. And so, what is the dimension of the U? U is equals to the what in here? Huh? U, what is the U? F. F. And so, this must be equals to the what? M times 1. M, for example, if we have the two input value, force and torque, 2 times 1. And also voltage value, voltage, force, torque, and so 3 times 1. Or, in the summary, M times 1. And so, what is the dimension of the B? Based on the Z dot, huh? Yes, thank you so much, Sarah. Okay? So, this is how we can calculate the dimensions of the states in here. This is called the state space. Have you heard of this? Huh? Okay. So, from the equation, we can write this form, z1 dot, z2 dot, which is equals to what? We have 2 times 2 matrices, that also z1 and z2, plus we have the 1 matrices in here with the what? With the ft, right? So, how can I fill these values? Z1 dot is equals to Z2, Z2 dot is equals to the what? Z1 minus K divided by M, Z2 minus C divided by M, Ft divided by M. How we can fill these matrices? Just help me. At the right hand side, we must know that Z1 is equals to the what? The Z2. So, we have 2 times 2 matrices in here. If the Z1 is included in the Z1 dot, no. Just follow me. Z1 dot possess the Z1. 0. Z1 dot possess the Z2. 1. Z dot 2 possess the Z1. Which one? Yes. Z dot 2 possess the Z2. Yes. So Z1 dot possess the FD. Huh? Yes. Z2 dot possess the FD. Yes. And so this is called state matrix. This is called the input matrix. Okay? We can build the what? The state space based on this information. But this is called the state space representation. State space representation. Okay? So, what is the advantage of these terms? First of all, both x and x dot are observable right now. If we solve this equation, and so we can easily reach at the same time x and x dot, right? Because we have it in the states. See? Secondly, we can apply multiple input, multiple output. Right, Ozan? We can write it because we can expand this equation into the what? Into the another form in here. So we have the A matrices in here. This is a first order system. Just remember that in the first order system, what is the solution of this term? X dot is equals to what? The AX. What is the solution of this equation? What is the solution? Tövbe estağfurullah. Nasıl zero olsun abi? X dot eşittir A çarpı X yani. Exponential term AT times X zero, right? Just remember that. This is the exponential term. This is the simplest solution for the first order differential equation. And so, this is useful definition. To what? To check the stability analysis based on this information. If we have the first order system, and so we can apply everything related to the first order system. Which means that we can utilize the useful mathematical theorem to what? To provide the stability, time response, or any other feature with the definition of the first order. First order is the good and the explainable, or the some useful property to what? Study in the time response. So we can check the condition or the time response of system just looking or examining to what? The A. If we check the eigenvalue of the A, or if we check the elements of the A, we can reach to the what? The stability, time response, or any other feature related to the system dynamics. And so, just remember that this A contains both X and X dot, right? See, in the transfer function, we don't have such kind of property. But if we look at or examine or evaluate the matrix of the A, and so we can reach the total dynamic, total properties of this system. Do you get it, Ozan? And also, the nonlinear form can also be added in here. How we can do that? Just see that this is the one. if we add the x1 or no z1 in here, so this is non-linear. See, this the variable coefficients are included in the system, just like this one. Do you get it? Okay. And also we can take the output of this system, y, c times x or z, I'm sorry, z plus d times u. What's the dimension of u? M times 1. What's the dimension of this term? N times 1. This y is called to the what? To the output matrix. Okay, this c is the what? Is the observation or the output matrices in here. For example, we have x and x dot, right? If the x and x dot are measured by using the sensor from this system, and so this must be equals to the what? N times n. This is equals to the what? N times n. For example, if I have the z value in here just like this one, the c can be built with what? 1 0 0 1, and so z is equals to what? The z1 and z2, right? And so in the first place we have the what? The y is equals to the what? The z1 and z2. These are two separate measurement results coming from this system. We can define it in here, but we have only possess the values of the what? Position. We have only one sensor, not two. We should write the c is equals to what? 1 0 0 and 0, right? Why? Huh? Ne oluyor ya? Yes, Z1 is the position, and so we have only measure this value in here. Okay? Or if we want to measure the velocity, huh? 0 1. Or if we want to measure the z1 plus z2, we may have utilized this value also. How we can build the c? Yes, 1 1 0 0. Okay, d must be set into the 0 because we will talk about it. Okay, it's a complex case for the what? For the system. And so our general notation z dot is equals to what? The az plus bu, and also y cz plus du. This is called state space representation of dynamic system. Okay? Any question? This is the measurement matrix. So we have another important topic about this term. If this is the state space, and so we can convert TF to SS or SS to TF. We can convert state space into the TF, or we can convert the TF into the SS. But how we can do that? First of all, x dot is equals to the AX plus BU, and also y CX plus DU. Okay? These are the state space form. If we take the transfer function in here, or the Laplace transformation in correct meanings. LP. This is equals to the what in here? SXS is equals to the AXS plus BUS, right? And YS is equals to what? CXS plus DUS, right? Because XS is equals to what? Is the first derivative, and so we can take the what? The Laplace transform in here, apply the Laplace transform, and we will get it, right? So, how we can reorganize this equation in here? Just see that if we use this term a times xs, if we put this equation to the left hand side, this is equals to what? The s minus I xs in here, bus. This is the identity vector in here, okay? Because the A 2 times 2 matrix, or the n times n matrix, and so S is a scalar, and so this I must be also n times n matrix here. This is the B times US, okay? Or we can turn into the what? If this is the vector form or the matrix form, XS is represented with the what? With the inverse value, SI minus A inverse times B times US, right? This is a simple matrix operation with the inversion form, okay? And so this is the XS, and so we can put this XS into this term, the output matrix, right? And so we can return into the what? The YS is equals to what? The C times SI minus A minus 1 times B times US, right? This is simple. And also we have the D times US, right? And so how we can collect the whole term in here? YS is equals to the what? The C SI minus A minus 1 B plus D times US, right? And if this is the case, how we can define the YS US value? This is equals to what? The C times SI minus A inverse 1 B D. And so this is the method of the what? SS to TF. If you have the A and B and C and D, you can convert everything into the what? Into the transfer function based on this theorem. But how many transfer functions are obtained in this matrix? How many? Yes. 2TF are generated from the solution of this matrix. Okay? This is simple math, guys. There's nothing in here. Okay? Guys? Do you get it? Ozan? Okay. So, as always with you, we need to build the what? The example. Beyza, could you help me in this example? Yeah? Beyza, could you help me? And transfer function, not two. Okay? And transfer function. Beyza, L, and we have the C friction factor in here, just like this one. Okay? and we have the theta value in here, okay, and also we have the moment mt in here, okay. And so our question is that, first of all, derive equation of motion, and after that obtain transfer function, and also obtain the state space presentation. Okay. This is the length of to what L. So Beyza, yardım edeceksin mi? Yok mu? Tamam. Başka birini bulalım. Ozan. Hadi. So, first of all, if this is the system, okay, so we need to determine which forces should be applied on this system. If we have the gravity G like this one, and so we have the two factor in here with perpendicular to the what to the m. What is the values of these terms? Yes, mg cosinus theta, and so this is mg sinus theta, right? But this is parallel with the L, which means that no, there's no moment coming from this force, right? But this one is effective because we have the perpendicular relation in here, okay? So this is L, this is the C, is the what, the friction factor or the damping coefficients of these terms. And so, as always we do, delta moments must be equals to the what, Ozan? Yes, theta dot dot, right? And so I is equals to ml square. This is the simplest implementation of the what, inertia calculation for the point mass, right? And so in the second place, we need to continue with the what? With our equation of motion. So I times theta dot dot must be equals to the what? We have the moment in here, right? And so we need to add this one because the direction of the theta and moment is same. And so the other ones, for example, the C. How we can continue with writing this equation, Ozan? Yes, because the friction is always in the reverse direction of the movement, right? And so theta dot times C. And also yes, why? Yes, mgr sin theta. Okay, this is our to what? This is equation of motion. Okay, this is done. So in the third place, we need to take this I value, or we should write the theta dot dot as a single term in here, right? How we can do that? We have the I value in here, and theta is equals to the what? This is considered theta, right? For the small angles. Otherwise, this is a non-linear small angles. Okay, this is considered as a theta, and so theta minus mgl, right, divided by with the what, with the I. What's the values of the I? Huh? ml square, right? And so we have also theta dot, and so minus C divided by, yes, ml square, and plus mt times ml square, right? This is R to what? are dynamic. Şimdi bir şey söyleyeyim. And so, Ozan, just help me. In the first place, SS can be written as we have second order system. How many states are included in the system? Yes. Z1 is equals to Z2. Yes. Z1 dot Z2. Z2 dot or Z1 times minus G bölü L, because it's the simplification of this term. Z2 times Ozan. Yes. And MT times. Yes. These are the basic form. And so, if this is the case, and then we can write the whole equation in the fifth. The SS can be defined with the what? With these terms. Theta dot, right? Which is equals to the what? 0 and 1, and minus G bölü L minus C divided by ML square times theta dot, right? Plus 0, 1 divided by ML square times moment. Okay? This is equals to the Z1 dot. This is equals to Z2 dot. This is equals to Z1. This is equals to Z2. See? This is the case. And so this is the state space formation of these terms. In the MATLAB session, I will explain how we can model this term in the MATLAB Simulink, okay, in the discrete form. But first of all, we need to talk about the force transfer function. Okay, force transfer function x0, 0, or theta. I'm sorry. Theta 0, theta dot 0 is equals to the 0. Okay, and so our equation is equals to the what? Is equals to these terms. Okay, these terms, and we can write that the s square times theta s plus s theta s times minus c divided by ml square plus theta s times g divided by l, right, which is equals to ms times 1 divided by ml square, right? This is our equation of motion in terms of the transfer or the Laplace domain transformation. This is simple. Just apply this equation to what? To Laplace transformation. And so, if this is the case, we can collect the theta s value just like this one. S square plus s minus c ml square plus g divided by l, which is equals to what? The ms times 1 divided by ml square, right? And so if this is the case, and theta s divided by ms can be written like this one: 1 divided by ml square s square plus s minus c ml square plus g divided by l. And so how we can write the angular velocity transfer function in here? Yes, this is so simple. ws is equals to what? S times, or s divided by ml square divided by s square plus s minus c l square plus g divided by l. Okay, see, this is simple, but in the book please solve 5 2019 and solve 560 examples in Palm book. Okay.